So this little exercise is going to look at differentiation using the quotient rule. We have a little formula up there in the corner. We're not going to worry about where it comes from, we're just going to learn how to use it. So in this formula there is v, which represents a function, and there's u, which represents another function. In the formula we have v multiplied by the differential of u minus u times the differential of v. And the whole lot gets divided by v squared. Okay. So we're going to take this formula and apply it to this problem here. We're trying to find the differential of x divided by x minus 2. And of course, x cannot be 2, or we end up with a division by 0. So, for this particular thing, u represents the numerator, the number on the top. I'm just going to write that down, u equals x. V represents the denominator, x minus 2. And what we have to do to use this formula is to work out the differential of u and the differential of v and plug them in. Here is u. The differential of u in this case is going to be 1, because that's x to the 1, and v, same thing applies. It's going to be 1 because the constant disappears when you differentiate. So v prime equals 1 also. We then just take these pieces, plug them into the formula, and we write that x minus 2, which is v, multiplied by 1, which is u prime, and we subtract from that the u, which is x, multiplied by v prime, which in this case is 1. And we divide the whole lot by v squared. There's no need to work this out. There's no need to multiply out x minus 2 squared. We just leave it in that format. So 1 times that minus 1 times that, x minus 2 minus x, all divided by x minus 2 all squared. X minus x disappears, and you're left with a final answer of minus 2 divided by x minus 2 squared. All looks rather abstract, but that's what we have. dy by dx is equal to that. It's possible to use some graphing software such as Desmos to plot this function here and to plot its differential, and to actually see for yourself that indeed this function does show the slope of that function as x changes.